My name is Charles Martin. I own a small farm in west central Illinois near Galesburg, which is about halfway between Peoria and Quad Cities. It's rolling country. It's in the Spoon River Valley watershed area. Most of my farm is highly erodible, so that's one of the reasons why I chose this project. This project was funded by a farmer rancher grant through SARE, which I'm very appreciative of. And my mentors have been Gabe Brown of Regenerative Agriculture. Have you all heard of Gabe Brown? Okay, good. And especially Dr. Kenneth Albrecht from the University of Wisconsin, who was the real impetus for me getting this grant. I have a lot of appreciation and respect for him. I got a chance to meet him on the last day as he was leaving the University of Wisconsin, so I consider myself very fortunate. I'm not going to spend a whole lot of time on the project details themselves, because the SARE final report goes into much more extensive detail. And if you go on to the SARE website, the North Central SARE website, and look up this number, FNC 19-1178, you'll be able to get to that. I also gave a presentation last summer, which is on the internet, and there is a final report video also, which goes into a lot more detail. That's why I'm going to skip over most of the videos that you see in this project. I have a handout up here which continues the perennial ground cover research, and it is in much more scientific detail. It's a replicated trial, and so I really encourage you to come up afterwards and get a copy of that. There's a backstory on this. I used to work for New Mexico State University, and when I started working there, Tony Valdez, the extension agent in that county, told me of a problem that they've been having because they furrow irrigate, and they raise their beds and then irrigate down the furrow. And because the soil is so sandy, they were losing a lot of soil. We worked with cover crops to help build up the organic matter, and in fact, we tripled the amount of organic matter in 3 years' time. But when you consider that the starting point was 0.5% in that sandy soil, you'll see that really didn't amount to much. The research models that I used, as I said, are mostly from Wisconsin through Dr. Kenneth Albrecht. And this is a picture of the ideal end result that I was trying to get. This is using currant clover, which is a perennial rhizomatous. It's very hardy. It's very drought resistant, and in Dr. Albrecht's case, it was used. It's herbicide resistant. My project was organic. I mean, it wasn't certified organic. I'm not certified organic, but the project did not use any herbicides or fertilizers. Basically, just to summarize, I established the cover crop. It took 2 years to establish, and so that's why we did have some weed problems along with it. Then it was flail mowed, strip tilled, and I inoculated the seed with mycorrhizae. Then we planted it in the strips, and because Do you all know about strip tilling? Okay, good. I don't need to go through that then. There are still some problems with strip tilling that we found, and one of them is the fact that the strip till loosens up the soil so much that when the rains come, they'll wash down that strip, and the sod to either side will hold it, but it will erode out through that. So, like I said, I took 2 years to just to build up the soil with mixed cover crops. No fertilizer, pesticides whatsoever, and just lime. Problem with the curl clover is it's very slow to establish. There's a saying with perennials, it sleeps and then it creeps and then it leaps. And one of the problems was that this was just a 1-year project, and really it would have taken 3 years for it to get established, a proper establishment. So the second year I planted a mixture, much more diverse mix: white clover, balansa clover, some grasses, and forbs. My neighbor has a flail mower, so he flail mowed it, and this is what it looks like before strip tilling. I do want to show you this. Now the strips are 8 inches wide in a 30-inch row. So that only took up less than a quarter of the area, still leaving about 3/4 of the cover crops intact. I didn't know how it was going to go at first. We're just going to skip through these. This was on the day that it was planted. Unfortunately, we didn't plant on the same day that we strip tilled, which is what I would have liked in hindsight. But a rain came and knocked down the strips, which might have made a more firmer seed bed. And this is what it looked like after planting. We also, I really encourage anybody to make their own Johnson-Su bioreactor. Have you all heard of the Johnson-Su bioreactor? Is there anybody who has not? Okay, just briefly, Dr. David Johnson of New Mexico State University developed fungal dominant compost system that's static. It's a static composting system, so you don't turn it, but it allows the air to go through these channels in this bin, and that allows the fungal population to build up. And when you get a higher fungal to bacteria ratio, you get a healthier soil in the long run. And I'm not going to go into a lot of details about that. Because it was just a 1-year project and the bioreactor takes about a year for it to fully mature, I bought this microbial biological inoculant instead. And this is what the seed looked like before. And then, because the open strips are also susceptible to disease, to weeds, especially the fine-seeded weeds, we overseeded with a mixture of cover crops. And this is what the planting looked like. sounds like a jet engine taking off. This is an air seeder. And it cleaned out the rows really well. You can tell that the furrow cleaners came right in there and allowed the planter to get right in there. This is what it looked like afterwards. Now 2 years of organic matter buildup really helped the tilth there, but the strip tilling helped also. Now the results, one of the problems was I didn't have a sophisticated guidance system, and we didn't have RTK on it. So you can see that the corn came up just off of the center. Now in a regular strip tilling that might not be a problem, but it's a problem especially in the cover crop, the strip tilled system. Because the cover crop competed against the corn. You can see how it's yellowing there. One of the benefits of the cover crop was the infiltration rate, and I'm just going to run that. It took about 14 seconds for it to infiltrate in the cover cropped area. So here we are. So the weeds didn't, we'll go back here. I'll show this a little bit. So here we are underneath the canopy of the healthiest corn. It's about this height, let's see.
Well, the very tip would be head high, but if you were going off leaf collars, you could be mid-chest, mid-torso range. But for as late plant as that is, look at this green color. This is beautiful. I mean, we have a little bit of, looks like potassium deficiency right there. Fundamentally, this is a good looking stand. And look what's next to it. Look at this clover that we've got. And I mean, there's some other diversity in here too. And yes, we've got some annual weeds that hopefully will be choked out. Here's a big velvet leaf we don't like. And then there's some barnyard grass too, but here's that. Is that cereal you were talking about?
The biggest problem was the weeds in the row. The overseeded cover crop was not dense enough to really, and it just landed on the surface, so it never really got started. And as a result of that, we still had a lot of weed pressure in the row. And a big contributor to that was the tillage promoted the small seeded annual weeds, especially foxtail and mare's tail. We had a huge problem with mare's tail in the row, and then later on in the season, water hemp. And you can see this is because of the size of the seed, just dropping down. It doesn't take much for it to get started. So we did see increased organic matter. We did see increased soil microbial activity, water infiltration. The crop bricks, that is the ears, had an increased bricks relative to the control. And but we did have increased weeds in the row. I want to go down here and highlight, you see where the wavelength and intensity shifts from the reflection off the green cover. Independent research has shown that the light reflecting off of a cover crop back up into the canopy will actually detract from the maturation and the development of the ear. And they found that out the hard way, and this is kind of testimony to that. So we had decreased yields, but if you want to see the details, again, go to that final report. So I was able to partner with a researcher from Kansas who saw my final report, and he contacted me by email. His name is Brandon Schlautman. He's a really excellent, he works with the Land Institute. Are you familiar with the Land Institute? They're doing some really, well, at the time they were doing some real cutting edge research. And he collaborated with me on another project afterwards to look at some other native species. And so that was a couple of years ago. So this is his first publication out of that. So you can come on up afterwards and get a copy of that. And then Dr. Raj Raman formed what's called ReGen, which is a perennial regenerative crop system. This is specifically in corn and beans. Now, because you can strip till corn and beans, now these were not organic. Neither one of these projects were organic, but they used Roundup sprayed over the row. They were able to decrease the glyphosate use by 75%. So when you consider that the dominant cropping system in the Midwest is corn, beans, if you can cut down the herbicide use 75%, imagine what that would do across the Midwest. I got interested because Balansa clover was part of the cover crop. I got very interested in Balansa clover, and I think it has a lot of possibilities for this kind of a system. It's not a perennial per se, it's a reseeding annual. So if you've planted in the fall after your crop, it will overwinter and then it'll spring up in the spring, the following season, and it's really, really productive. It will produce about 125 pounds of nitrogen to the acre. And what I liked about it is it's hollow stemmed, so it roller crimps real easily. So instead of flail mowing it and then having that litter break down too fast, if you roller crimp it, it lays down on the ground like a mat. And I would like to apply, in fact, I applied for a follow-up grant using Balansa clover, but it got rejected. Other people have tried white clover, again with mixed results. Some say it's too vigorous, some say it's not vigorous enough. My experience with white clover is that it's too vigorous. It grows back in too fast, and it will overtake the crop before it really gets established. Brandon Schlautman uses dwarf bluegrass, and that works pretty well for their system. But again, that's not organic. This is an example of Balansa clover, roller tilled for late planted corn. Now, if you really want it to reseed, you have to let it go to full bloom. And it doesn't really go to seed until June. But you can still get some benefits if you hold off until late May by roller crimping it. There's an overall trend in corn and beans to move away, especially corn, to move away from wide rows. My project was planted on 30-inch centers, but a lot of farmers nowadays are going to 20-inch rows. And the problem with that in this kind of a system is you have an 8-inch strip on a 20-inch center, and you're taking up about half of the cover crop. So I think the movement is going to be go more towards an actual equidistant planting system, where you can get narrow rows, but also have a wider space in between each plant. There's a farmer slash engineer near me. He designs and builds his own corn heads. It's the Calmer Corn Head Company. You might have heard of him. He's kind of a mechanical genius, and he had a custom request for a 15-inch corn head. And the problem there is that everything else has to be dropped down to 15-inch centers. And so it worked for this farmer, but on a larger scale, it still has to be worked out. There's another idea about just high density sunflowers. I have that printed out here too. So you can either come up and pick up a copy of that, or you can take a picture of this and find it on the internet. These are the references. This is Dr. Raj Raman's email if you want to contact him, and Brandon Schlautman's also at the Land Institute. And again, just to reiterate, the final report is down there at the bottom. So I want to thank you all. This was the final result, and you can compare that to what was at the beginning. You see that the cover crop filled in real nicely, and it did suppress a lot of the weeds. But also look, if you see, the corn stalks are still too slender there, and it really cut down on the yield. So this is a learning experience. So thank you very much. I'll open it up to questions. Yes, sir.
Where was your plot at that you did this research on?
It wasn't really strictly research. It was conducted on my farm east of Galesburg.
Okay. And when you said reduced yield, what exactly was it?
It was considerable. It was about 80% loss in yield. Yeah, the cover crop just smothered the corn before it could really get up above. And I think a better alternative would be go ahead and green plant into the cover crop, and then wait until it's actually emerged, and then go in and either flail or roller crimp. They're doing that with cereal rye. They're planting green into the rye and then going over and roller crimping afterwards. I think that practice would be better for this system. Yes, sir.
You said that you were talking about significant yield reduction in the corn.
Yeah.
How much of that do you think was attributable to the cover crop absorbing available soil moisture?
Well, based on the research that these other scientists did, they started out and they got a decrease in yield. I think it was about 20 to 30%. If you contact Brandon, or it might be in in the article itself, I think they got at least about a 15 to 20% drop in yield. But when they started going to overspraying it to turn the cover crop brown and then let it grow back during the summer, they got comparable yields, either comparable or even better yields using that system. But again, that's with the conventional herbicides.
It would just seem to me that you're setting yourself up there in a situation where a late season, really hot dry period like in late August, boy, that cover crop would compete really strong for the moisture. Does that make sense?
Yeah, since this was sweet corn, by August the season was over. We didn't have any, so. But that's a good point.
So your test was done with sweet corn?
Yes. The reason I chose sweet corn is my neighbor across the highway raised sweet corn, but he raises it conventionally. So I wanted to use it as a comparison. So he agreed to plant his corn and my corn on the same date. We're using the same varieties and same row width and things like that. So it was, I can't say this was scientific by any means. This was just one single data point, but it kind of is indicative.
Was there extra, I know you said, was there extra fertilizer added at all?
Other than the microbial seed coatings, no. Yes?
I came in a little bit late, so you might have already gone with this, but I'm curious how much do you think your variety choices played into some of the issues you ran into? The reason I ask is I did a sweet corn, obviously we did a Three Sisters trial at SU, and the main issue I came up against was our varieties did not play nicely together.
Yep.
And so in the future, I would have picked different varieties.
That's an excellent point. Did you all hear that? The concern is that when you're planting two crops, a cover crop along, modern hot corn hybrids, whether they're sweet corn or field corn, are not developed, they're not bred under those kinds of circumstances. And there has been quite a bit of debate. I don't know, I haven't kept up with it, but when I was at NMSU, there was a strong interest in developing varieties that were suitable for this kind of intercropping system. And we did a lot of research on intercropping and interseeding, and so that's why it was pertinent for that condition. But I think that if we really want to use this kind of a system or something comparable, I think the breeders are going to have to go in that direction. Now, whether or not it's profitable for them, I mean, whether or not there's a big enough market for it to do it, but I think the organic growers would appreciate something that they can, because there's a lot of interseeding going on already. I mean, if any of you went to the O-Grain conference up in Wisconsin, that's what a lot of their research is on, is interseeding cover crops either along with or soon after planting. And I think it's the wave of the future myself.
What was the time of year and soil temperature?
Soil temperature under the canopy in mine was 86, and in the other, my neighbor's field, it was 93 degrees.
What was the soil temperature when you planted it?
Oh, what was the soil temperature when I planted it? I'm sorry, I didn't. I could have taken measurements, but I didn't record them down, so I can't say.
The reason I ask, it makes a big difference on the season bigger, especially when they're competing against a cool season grass or a legume. It's already got a jump start this spring.
Yeah, I agree. There are so many factors. I was just trying to simplify them, and I admit I didn't take all those factors into consideration. Yes, ma'am. Again.
I'm curious if you were able to look at soil quality or SLM between your plot and then your neighbor's plot at all?
Yes. Whose is that?
You're buying the first round.
If you go to the final report, you will see detailed comparisons. I sent the soil off to get Haney tests as well as microbial counts, and for sure the microbial count in the perennial cover crop was much higher than in the other one. Even more significantly, what I thought was really significant was the infiltration rate. I measured the infiltration rate over in his after rain, and it took about 20 minutes for a gallon to sink into the soil. The heavy rain will just, especially on a clay silt loam that we have, will compact that and it will just sheet over and it'll just run off. And I think that's one of the biggest problems that we have in the Midwest is it's not that the infiltration rate itself is so slow, it's that the tillage, and if you go in and tillage and then you get a heavy rain, it just sheets right over. And that's why I showed that, is that underneath the cover crop, it infiltrated anywhere from 14 seconds to 2 minutes. 2 minutes was the max. And I don't know how much of you are, go ahead, Nam.
Yeah, I'm curious.
Yeah, you had your hand up for a while.
Yeah, well, I was going to ask something else, but then when you're talking about infiltrating, what was that? So you were seeing how the water was going into the soil. What was that circle?
That's called an infiltrometer.
Okay.
It's a scientific measure. It's calibrated. Each ring is calibrated to a certain volume of water. So, and then the outer ring, the inner ring is where you put the water, and the outer ring is to hold the water within that circle. And I'll just go ahead and run that again. Look at the edges and look at the sheen on the soil, on the water surface there. That will give you an indication. When that disappears, that tells you that it's infiltrated.
Okay.
That's what I was using. And I was measuring, I had a stopwatch there and I was measuring the time from the time that I put the water in to the time that the water disappeared.
And you did that to see what your soil was like how it,
To-
because I've never done anything like that. I don't know.
Yeah, it's to measure the infiltration rate.
Because you were also saying that you worked the ground and then you weren't able to plant afterwards, right? You had to plant the next day because it rained.
We didn't work the ground. We strip tilled it.
Strip tilled it, yes.
And
okay.
I would have liked to have planted immediately after that, but Andrew Bowman, the farmer cooperator, he wanted to wait for two reasons. First of all, he had his own fields to work on, and then second of all, he thought that after a rain, it would compact and would give a better soil to seed contact. Yes. I don't think the soil to seed contact would have made much difference in this case because the organic matter is high enough already that it would have compacted naturally just from gravity. Any other questions? How am I doing on time?
You still have
Half an hour?
9 minutes.
Are there any of these other slides that you would like to see? Ma'am?
I haven't actually done a lot of research on the other intercropping that people have been doing, but do you know how this compares to like late season intercropping? I know people are doing it with robots, like seeding cover crop before harvesting the corn. Do you know about that research?
I do know about that research. there's a lot of interest in intercropping, especially one of the reasons why I went into international agricultural development is that in some respects the developing countries are much farther ahead of us in their sophistication and their combining of crops, because they're working from a point of subsistence. I mean, for a lot of these people, that's going to be the food that they eat, unlike us who markets it or sells it. And so if you want to look at that kind of, those kinds of research, I would go to, well, the Sustainable Agriculture Research Journal has a lot of that. And I was very fortunate enough to go to New Mexico, where the traditional systems of the Three Sisters is still very prevalent. And the selection of, you mentioned the corn selection. I wish I had brought the slide that shows the Native American corn varieties. They had like over 200 varieties, and you know, we have one. So, but you know, we have sacrificed diversity for productivity, and I can't answer that question. That's the farmer's dilemma nowadays. I know when I was growing up, we had a 4-year rotation based on, it was actually based on the horse. My father he worked the fields with horses up until World War II, and he and my grandfather farmed that way. So they were used to 40-inch rows, so they get the horses and the carts down them. So imagine how much that has changed nowadays. But like I was saying, in New Mexico, where they still use the Three Sisters planting system, the corn, beans, and squash, and they're still more traditional in the sense that they grow their crops for the flavor and the yield, not just the yield, but the flavor. The families, the traditional growers, have their own family line of chili that they have kept going for 400 years. And it's really, it's just outcompetes anything that you see on the market. So, are there any of these slides that you want to see? This one I think might be interesting.
Like this with their strip tiller
measured the cover, it was at least a foot to 14 inches high, in clover. And so the clover would have shaded out.
Yeah, yes, exactly. So we absolutely did the right thing, but I think that's what A has to figure out first.
Are there any other slides you'd like to see? Ma'am?
I just wanted to tell a quick story. So when you were mentioning about the horses, my dad's 92, and he told me the other day when Joe, their farmhand, so this was in the 30s, my dad's dad sold the horses, and the farmhand cried about it. Those were, he took care of those horses.
Yeah.
And then what he bought, and then my dad's dad bought a tractor.
Yeah,
And
yeah.
replaced the horses. And yeah, that, I thought that was pretty cool.
My grandfather never learned to drive a tractor. So it took my father to move the farm forward.
Yeah.
But I mention that because the old traditional system, the crop rotation system, was really much more sustainable in the long run. I mean, it wasn't more productive, but it was more sustainable because the typical rotation was corn, beans, oats, and alfalfa. And the corn and the beans were cash crops, and you had a grass followed by a legume that would take up any extra nitrogen. Then you had another grass, you had oats, which were fed to the horses and cattle, followed by alfalfa. So you had a corn, you had a grass, legume. So it built up the soil. So you only had to plow like once every 3 or 4 years. So the other thing that it did was it broke up that pest cycle. So instead of having the same pests come in, now they're going to continuous corn, which I think is just a bad mistake. But some of my neighbors do it, and they say, "Oh, that's the way to go." So, and they're getting good yields. They're getting 300 bushel yields nowadays. You can't knock that. Well, I want to thank you all very much. Thanks for your attention. And again, you can go to the website if you want more information.